Imagine a machine so massive you could walk inside its cylinders, so powerful it consumes the equivalent of 250 cars every hour, and so enormous it takes 100 people just to assemble a single component. These mechanical monsters literally move the world, carrying 90% of global trade. But how the hell do you build these steel beasts? Stay with me, because what you're about to see will blow your mind. The largest engines ever built aren't in race cars or military jets. They're sailing across oceans right now. The Wärtsilä-Sulzer RTA96-C is the world's largest engine. 14 cylinders, 89 feet long, 44 feet tall, and weighs as much as 2,300 cars combined. To put that in perspective, it's taller than a 4-story building and longer than a blue whale. Each piston in this giant measures almost 3 feet in diameter. Think about it. You could fit your entire head inside a piston bore. The connecting rods weigh 5 tons each. That's like 4 complete automobiles. The crankshaft is a masterpiece of engineering, forged as a single piece of steel weighing 300 tons. To move it during assembly, you need special cranes and a team of 50 people coordinated like an orchestra. This engine produces 108,920 horsepower, enough to power a city of 100,000 people. Its fuel consumption, 1,600 gallons per hour. That's more fuel than your car uses in 6 months every single hour. Building one of these titans isn't just assembly. It's a symphony of extreme precision. It all starts in foundries where steel is heated to 2,900 degrees Fahrenheit, hotter than volcanic lava. Cylinder blocks are forged using hammers, delivering 15,000 tons of force. Imagine the weight of 150 blue whales hammering metal into shape. Each blow creates seismic waves felt miles away. Then comes machining. CNC machines the size of houses carve each surface with precision down to thousandths of an inch. A single error here could cause a catastrophic failure when the engine is pushing a 400,000-ton cargo ship. Assembly takes 18 months. Teams of specialists work around the clock, installing 300,000 individual components. Each bolt is torqued to exact specifications, some requiring 2,000 pounds of force to tighten properly. But here's where it gets crazy. This engine operates at just 102 RPM. That's slower than your car at idle. Yet each combustion event creates pressure equivalent to 200 atmospheres. Imagine the weight of the ocean pressing down on every square inch. The cooling system alone is mind-boggling. It circulates 1,400 gallons of coolant per minute through passages wider than subway tunnels. Without this, the engine would melt itself in minutes. During operation, combustion temperatures. Before shipping, each engine undergoes 200 hours of testing. They're run through every possible scenario: full load, emergency stops, extreme temperatures. The test facility shakes like an earthquake when these monsters fire up. Moving a completed engine is an operation in itself. It requires specialized transport ships, reinforced railways, and road closures. The logistics cost alone can exceed $500,000. Once installed, these engines run continuously for decades. Some have operated for over 30 years, consuming millions of gallons of fuel while carrying everything from cars to computers across the globe. The next time you see a massive cargo ship on the horizon, remember, inside that hull beats the heart of one of humanity's greatest mechanical achievements, a testament to our ability to engineer solutions on an almost incomprehensible scale. These giants don't just move cargo, they move civilization itself. What other incredible machines would you like to see? Drop your suggestions in the comments, and don't forget to subscribe for more engineering marvels that will change how you see the world.